Good morning to all. Are you able to hear my voice? Good morning to all. Are you able to hear my voice? Okay then. So we'll start the class. In yesterday's class, we were unable to complete the sources. So I will start with sources. So as I have already discussed, source is a device which can convert mechanical, chemical, thermal or any form of energy into electrical energy. So here we are going to discuss only about the electrical sources. That's why I'm telling you that the other forms of energies are converted into electrical energies here. So sources can be mainly categorized into two types. One is the voltage source, other one is the current source. So voltage source, you can see these are the symbols of the voltage sources. So voltage source may have two, you can represent voltage source with two electrodes. So positive electrode and negative electrode. As you can see here in this first image, this is the positive electrode, this is the negative electrode. Positive electrode will, the length of the positive electrode should be always drawn longer than the negative electrode length, and you must always mention plus symbol at the positive electrode and minus symbol at the negative electrode. Usually in general we won't call them as positive and negative electrodes, we call them as positive and negative terminals. So usually ends of a branch are called as terminals. A and B are called as, usually in general A and B are called as terminals, but you can even call this electrodes, this positive and negative electrodes as terminals. You can even represent the voltage source by a circle mentioning plus and minus at either end of that circle, and you can write V besides to those besides to this positive and negative electrode terminals, or besides to this circle. So this represents the voltage source symbol. Okay, so as I have already told you, these are the voltage sources, batteries and alternators. Similarly, if you go to the current source is represented by a circle. It is represented by a circle with an arrow mark inside it. So it provides the required current for the circuit elements that have been connected in the given circuit. Similarly, the voltage source also, it provides the required voltage that is required by the circuit elements in the circuit in which this voltage source has been connected. So the current sources examples are photoelectric cells, that is solar panels, or transistor. So now the sources, that is voltage source and the current source, the voltage source and the current source, these two sources can be classified further into DC sources and AC sources. Okay, they can be classified into DC sources and AC sources. If you consider DC sources will always provide constant voltage. They will always provide constant voltage or constant current. So DC source can be a DC current source or a DC voltage source. Okay, DC sources are further classified into DC current source and DC voltage source. So if whether it is a DC voltage source or DC current source, both the sources will provide a current, means the current that is flowing in the circuit because of the DC voltage source or current or DC current source will be always constant, and it will always flow only in one direction. Okay, and DC represents direct current. DC source means direct current source. DC source means direct current source. DC current sources can be DC current voltage source or DC current source. So this is a representation of DC current voltage source, a circle with plus or minus symbol, or you can this is also this which I have already shown you. This is also a DC voltage source. You can even represent like this, or you can represent like this, DC voltage sources. So if it is a DC current source, usually you will draw a circle and put an arrow mark. The direction of the arrow mark shows the direction from the terminal from which the current will enter into the circuit. So you can see here the arrow mark of this circle is upward. That means the current will leave this source from this terminal and it will enter into the circuit elements in whichever direction, right side or left side, in whichever direction the elements have been connected. Okay, so this is our DC voltage source, this is our DC current source. So examples of DC sources are batteries, solar panels, AC to DC converters. Okay, so usually DC supply, okay, DC sources are required to energize the electronic devices. So mostly in order to energize the electronic devices, DC sources are used. So if you go to the AC sources will always provide the alternate, I will show you the image, yeah. They will always provide the alternate voltage or alternate current. So you see, just now I have discussed about the DC current. So in this DC current, what you can see is, you can see here, even though time is varying from 0, this is 0 terminal, wait, if I will take a pen, so this is it, a ballpoint pen. So let us assume this is 0, this is 0 terminal, okay, this is 0 terminal. I will change the ink. Color change, I will change it to red color. Okay, now this is our origin, isn't it? This is our origin. The from 0 interval of at this origin the time will be 0. So at when time is 0, you can see there is some voltage. This is the voltage on y axis, on x axis time is there. So this is the voltage at time 0. So at interval of when the time interval is 0, you can see there is some voltage V. Let us assume this value is V. So as time increases, what is happening to this voltage? Voltage still remains V. It is not varying. It remains constant. Okay. So if it is a DC current voltage source or DC current source, here I have written voltage. The characteristics of current with respect to time. So instead of voltage, I can write current here. So for current or voltage, it is same. Okay, you can write voltage, or you can write, I'm sorry, you can write current. So whether it is voltage or current, with respect to time, they will remain constant, whatever may be the time. Okay, up to from 0 interval to infinite time, they will remain constant if it is an ideal case. Okay, so nothing is ideal in practice. Practically nothing is ideal, but in order to study theoretically, we will assume the ideal cases. But if you observe the voltage source of an alternating quantity, so AC means alternating quantity actually. Okay, you can even in general people call it as alternating current, because it is easy to speak out, because its abbreviation is AC. So usually in general people call it as alternating current, but it is AC means it means alternating quantity. Okay, not alternating current, but in general people call it as alternating current. So you can see here voltage waveform. Okay, magnitude is voltage and x-axis time. You can see how as time gradually increases, you can see voltage is increasing and decreasing. Again next, voltage is increasing in the negative cycle, and again it is increasing and decreasing. So if suppose this is the peak value, this is the peak, isn't it? This point is known as peak value. The peak value is plus V in this positive side. In the negative side it will be minus V. Okay, so gradually from 0 interval of time, from 0, so voltage is 0 at this instant, voltage 0 at time, when time is 0, at time is 0, voltage is 0. As time is gradually increases, voltage also increases at this interval of time. At this particular interval of time, what is happening? Voltage is becoming maximum, so it is plus V. And later what is happening? As time is further increased, voltage decreases and it becomes 0 at this interval of time, at this particular instant. Okay, so you should not call it as interval. It is at this particular instant it is becoming 0, and further it is decreasing and it is becoming maximum in the negative scale. Okay, in the negative cycle it is becoming maximum at some interval of some t1. And further, when time is increasing, current voltage is decreasing here. Same case. Okay, same case, similar to voltage, you can even write current waveform will also be same for both alternating voltage or current waveforms, both will be same. Okay, so I hope we are able to, I will discard this, I will not end this, but I will erase all these things. No, there should be something. Erase all links. Yeah. So you can see here. So direct current means the magnitude of the quantity will remain constant, whether it is voltage or current, with respect to time. If it is alternating quantity means the magnitude of the voltage or current will be continuously varying with respect to time in a sinusoidal form. You can see a sinusoidal wave here. Okay, here in this it is a sinusoidal wave. The alternating quantities, they can be either square waves, ramp waves. Okay, so different types of alternating quantities. You can how it is, why we are calling it as alternative? Why? Because up to this interval it is increasing in the positive side and it is decreasing. From this interval, from this instant to this instant, it is increasing in the opposite side. Okay, alternate side. Okay. If this is positive waveform, this is if this is positive cycle, half cycle, then this is negative half cycle. Again it is positive cycle, next negative, again it is positive, and this process continues. Okay, so you are getting half positive cycle and half negative cycle. So it is alternative in nature. That's why it is called as alternating quantity. So alternating quantity sources, or you can call it as AC supply. In general, in our houses, the supply that we get is AC supply. Okay, so as time varies, what is happening? This quantity is also varying, and we can get variable free powers for this AC supply, as well as variable we can get variable frequencies, means frequency is reciprocal to the time period. I hope you know what is meant by time period. If not, I will discuss later. Time period is time taken to complete one cycle. One cycle means this is one positive half cycle, this is one negative half cycle. So one positive half cycle and one negative half cycle together, okay, together it is known as time period. This is T. So from here to here, this is known as time period. So if I want to determine the frequency, frequency will be equal to 1 by T. Frequency is equal to 1 by T. So where T is the time period. So let us see so let us see how they are represented, whether it is AC voltage source or AC current source. Okay, they are represented. How they are represented? Their symbolic representation I am telling. I'm talking about symbolic representation of these sources. So if it is an AC voltage source, it is represented by a circle with a sine wave inside, and if it is a AC current source, it is represented by a circle with sine wave as well as an arrow mark. Okay. So usually terminals of these AC sources will, for DC, as I said, positive, plus and minus. So here in the AC it is known as, the terminals are known as phase and neutral. Current always comes out from the phase terminal and enters into the circuit, and phase terminal need not be always on the upper side. You can even write like this also, since it is alternating quantity. Okay, phase terminal is not fixed. You can assume whichever terminal you want as phase, you can assume, you can consider it as phase. Okay. So, but for DC, if it is plus, you have to consider it as plus. If it is minus, you have to consider it as minus. You can't interchange. But in the case of alternating quantity, in the case of AC, you can interchange the phase and neutral terminus. You can consider any, if two terminals are there, you can consider one terminal as phase, other terminal as neutral. P represents phase. P means phase. PHASE. Okay. N means neutral. Okay. So these are the symbolic representations of AC voltage source and AC current source. Okay. So let us proceed further. Let us see types of network elements. So there are different types of network elements. So actually today's topic is our series and parallel. The thumbnail that I have prepared is series and parallel circuits. But before going into series and parallel circuits, we must have some basic knowledge on the basic concepts. That's why I'm discussing all these things. As soon as these basic concepts, basic knowledge that is required to go to series and parallel circuits content, we will complete this and we'll go to that, because without knowing all these types, means sources and types of network elements, it's of no use to directly go to series and parallel circuit element content. Okay, so let us dig into this. So active elements and passive elements, different network elements can be categorized into active elements and passive elements, linear elements and non-linear elements, bilateral elements and unilateral elements. So let us start with active elements. What are these active elements? Okay, so let us see what is meant by active elements. So active elements are those which can deliver power to the other elements, means which gives out energy to the other elements. So whichever gives out the energy means it must be having some energy, isn't it? It must be having some power. So whichever has some power, and if it is able to give that power to the other elements, such elements are known as active elements. Okay. So these active elements, they can deliver power. If required, they can absorb power. It depends. Okay. They can deliver as well as they can absorb the power. So examples of active elements are voltage source. Okay, you can see here, I have mentioned here, voltage source and current source. These two are the active elements. Now let us go to the next, that is passive elements. So passive elements are just, their function is just opposite to the active elements. Their function is, they can't deliver power or energy to the other elements. However, they can absorb power, means they consume energy. So active elements give energy, passive elements take energy. Okay, so they consume the power, passive elements consume the power, active elements deliver the power. Okay, so you can see here I am showing you three images. One is capacitor, one is inductor, and one is resistor. So in the yesterday's online class, so I was discussing about basic circuit elements. What are the basic circuit elements? Resistor, inductor and capacitor. So among these three, can you mention among these three, which are the energy dissipating elements. All these three are energy dissipating elements, or all these three are energy storage elements. Which is energy dissipating element, which is energy storage element? Can anyone mention? Energy dissipating element are dangerous? In the chat box, just, I'm sorry, not dangerous. Someone has mentioned here, some in chat. There is a question. Which is more dangerous, AC or DC? I just read it, and unfortunately it came out from my mouth. So you just mention which are storage elements and which are the energy dissipating elements mentioned in the chat box. Okay. Did you people, so I was just texting, giving answer to someone's question. So did you mention? So what are the energy storage elements and what are all the energy dissipating elements? Did you people type? So you just type, meanwhile I will discuss here. So as I have already discussed, resistors are the energy dissipating elements, capacitor and inductor are the energy storage elements. Capacitor stores energy in the form of electrostatic field, inductor stores energy in the form of electromagnetic field. Okay, now let us see linear elements. What is meant by linear elements? These are the elements that show a linear relationship between voltage and current. So if we are able to show the linear relationship between voltage and current, then when the current is flowing through these elements, okay, if current is flowing through these elements, and if we are able to show the linear relationship between voltage and currents, then such elements are known as linear elements. Example, resistor, inductor and capacitor are the linear elements. So when current flows through them, we can show a linear relationship between the voltage and current. Okay, so now non-linear elements. Okay, so non-linear elements means these are the elements which won't show any linear relationship between voltage and current. Okay, such elements are the electronic devices such as diodes and transistors. Okay, so bilateral elements are the one which allows current to flow in either direction. So for example, in order to understand clearly, I will just draw some arrow marks here. I will take a pointer. So this is a resistor. You can see there is a terminal here, there is a terminal here. So in this resistor, current can flow in this direction, or from this current can enter from this terminal and can leave from this terminal. You can see the arrow mark that I have mentioned, or current can enter from this terminal, okay, and can leave from this terminal. See, current is entering in either direction, okay, through this resistor. Okay, so if the current in an element can flow in any direction, okay, then such elements, it means if in both directions, okay, so in both direction, not any, in both directions, then such elements are known as bilateral elements. Okay, and when current direction has changed in the same element, where is the cursor? I'm unable to find my cursor. This is it. So I will end this. No. Oh, okay, now. Yeah. Yeah. So if the impedance of this element is not changing, even after the current direction changes, impedance remains same. Such elements you can call them as bilateral elements. Okay, so bilateral elements. Next, let us see unilateral elements. So unilateral elements means one second. Now, unilateral elements. So current can flow only in one direction in these elements. Current cannot flow in the other direction. Okay, so in electronic subject, your staff might have already taught you. So examples for unilateral elements is, okay, examples are diodes and transistors. So what will happen is, if current direction is changed, the impedance of these elements will also change. What is impedance? I will discuss later. Okay, not now. In detail I will discuss later about impedance. Now let us get into this few more basic terms that we have to learn before going to series and parallel circuits. So those terms are network terminology terms. So you can call them as network terminology. So let us discuss the network terminology, okay, in detail. So let us discuss the network terminology. So in network terminology, let us discuss what is meant by a network. Okay, let us discuss what is meant by a network. You can see here in this diagram, you can see there are two sources. This is a source and this is a source. So these sources are the this is a voltage source, this is also a voltage source. So am I online? Can anyone inform me? So you can see here there are two sources here. Okay, so we can say instead of one source, more than one source is there. So we can say this is a multiple source circuit, and you can see a resistor, inductor, capacitor and a resistor are there. So there are two active elements, I can say. This is one active element and this is another active element. Okay, so there are two active elements, and you can see resistor, inductor, capacitor and this resistor, they are the passive elements. So they will consume energy, and active elements, these two voltage sources, they deliver energy. Okay, so arrangement of various sources along with different passive elements or circuit elements in certain pattern is known as an electric network. So what is a network? So what is a network? Arrangement of circuit elements in a certain pattern. You can see in certain pattern they have been arranged here. There is a voltage source and there is a resistor, and parallel to, what is meant by parallel and series we will discuss today itself. There is an inductor, again capacitor, resistor and voltage. They have been arranged in certain pattern. So arrangement of network elements in certain pattern is known as an electric network. Okay. So now let us see what is meant by a node. What is meant by a node? Let us see. So here you can see I have mentioned there, I have taken the same circuit. I have put a line towards this dot where B is written, and there is a dot here where E is written. Okay. So this dot, I will take a pointer. So this dot, you know, whatever it is shown here, that dot where B is written and this dot where E is written, these two dots are known as nodes here. Why do we call them nodes? Let us see. So here there is a voltage source. This is plus symbol, this is minus symbol. As I said, from the positive terminal the current will come out from the source and it will flow like this. Okay, and here it will bend and it will turn, the direction of current is changed here, and it will flow through the resistor. After that it will come here. Okay, and from this source current will come out from this positive terminal. It will flow like this, then it will bend, its direction of the current is changed here, and from here it is flowing like this, from here it is flowing like this, and after coming to this junction, what is happening? Both the currents are meeting, both the directions are meeting at this point, and what will happen? They will add up, and summation of these two currents will flow through this branch and it will flow like this. Okay, and after coming at this node it will divide into two parts. Here it is adding up and entering this branch, here it will divide and it will flow like this, and it will enter the source from negative terminal. Here also it will enter the source from the negative terminal. So what is happening here? At this point B, what is happening? Current is adding up and entering into some other branch. At this point E, current is dividing and entering into other branches. Current from this branch is entering and it is dividing into two parts. Okay, so here what is happening? Current addition is taking place at this point, current division is taking place at this point. Okay, so at the point wherever current just divides or adds up, that point is known as node or junction. Okay, so but in general there is another definition for node. What is said that any two elements, meeting point of any two elements. If you see, this is a voltage source, this is a voltage source, this is the terminal, this is the terminal of the voltage source, this is a resistor, this is the terminal of resistor. Okay, So the terminal of voltage source, terminal of resistor are meeting at this point A. You can call it as a node, but there is no current division at this node. Okay, so it's better not to call it as a node. But there is a general definition for node. It is said that when two or more elements join together at a point, it is known as node. Okay, when two or more elements. So you can see here in this diagram. I will go to the arrow mark. So in this diagram you can see here voltage element and resistive element are meeting at this point. You can call this as a node, but since current division is not taking place, whatever current is coming from this positive terminal, same current just changing its direction and entering this resistor. So no current division is taking place, current is not adding at this node at this point. So you can call it as a node, but it's better not to call it as a node, because when at whichever junction or whichever point, if current division is not taking place or current is not adding up with any other current, so it's better not to call it as a node. You can call it as simply a terminal where two branches meet. Okay, or you can call it as a junction, you can say, but you can't call it as a node. But in to be more practical and to be more specific, okay, to be more specific, the specific definition for node is the current should be either add up or current should either divide at a particular point. So if current is adding up or current is dividing at a particular point, those points you can call it as a node. But in general, people say that the meeting point of two branches or two elements is known as a node. Okay, I hope you have understood what is meant by node. Let us see what is meant by branch. Okay, so here branches are the meeting points of the nodes. Okay, meeting points of the nodes are nothing but means if two elements are meeting at a point which you can call it as a node. Okay, so then such elements are known as branches. So to be more clear from this diagram, you can see there is an element voltage element here. So this element from A to F, this is one branch. From A to B, this is one branch. From B to C, this is one branch. From C to this R4 terminal. Okay, this is one terminal, this is one branch, this is one branch. And there is no element here, so forget about this is one branch. Okay, so these two branches, since they are connected in a same line, you can call this whole as one branch. You can even call that this as a one branch. But since this terminal of resistor is connected to the terminal of the voltage source, I have divided them into two branches here. Okay, so branch represents an element with two terminals. That's it, nothing else. Branch is nothing but an element, whether it can be either an voltage source or current source or a passive element, resistor, inductor or capacitor. Okay, so they are known as branches. I hope you have understood if you are listening to the class. So let us see what is meant by mesh or loop. So mesh or loop is nothing but, you can see here there is a voltage source. You just travel like this, you just observe the cursor, and I am moving my cursor from positive terminal of voltage source to point A, and from A I have turned my the direction of the cursor has changed to point B. After coming to point B, I am moving towards point E. From E I am moving towards point F, and again from F I am moving towards point A. So what is happening? I am forming a closed path here. Okay, so I am traveling in a closed path. Repeatedly and repeatedly I am traveling in a closed path. So similarly, if I start my journey from B to C, C to D, D to E, E to B. So this is also a closed path. Okay, so how many closed paths are there in the given circuit? There are two closed paths. This is one closed path, this is one closed path. Of course, one more closed path is also there. You can start from A, B, C, C to D, D to E, E to F, F to A. Okay, so this is one closed path. So total 3 closed paths are there, but individual closed paths if you want, to know the individual closed paths, there are two individual closed paths. Okay, so this closed path, that is A to C, C to F, F to A, it's not an individual closed path. It consists of two individual closed paths. Okay, so I can call this individual closed paths as loops. Okay, this is one loop, this is another loop. So since they are closed paths, I have drawn a circle here. Okay, I have mentioned loop 1 and loop 2. Okay. So if suppose I remove this branch AB, if AB branch is removed, what will happen? There will not be a closed path, the closed path will be open. Okay, closed path will be open, it will no longer be a closed path. Similarly, if any of these elements, for example capacitor is removed, it will no longer be a closed path. Now you can see I have drawn two loops here, loop 1 and loop 2, and I have mentioned some arrow marks. So what is the direction of these arrow marks? Is it clockwise or anti-clockwise in both the loops? Someone mention in the chat. Is it clockwise or anti-clockwise? Is it clockwise or anti-clockwise? Both the loop directions. I have drawn two circles, isn't it? These two circles are two loops. So what is the direction of these loops? What is the direction of these loops? Nobody is responding. It's clockwise or anti-clockwise? How is it? Clockwise or anti-clockwise? Okay, so let us go to the next, that is linear and non-linear networks. So linear and non-linear networks. So before going to that, so okay, so here you can see both the directions are clockwise. Okay, so you can see I have started my journey from here. I am moving in the clockwise in this loop. In this loop I am moving in the clockwise direction. So the loop directions, you know, I have mentioned both the loops directions as clockwise, but your wish, you can assume any direction that you want for the loops. Okay, in the given circuit they didn't mention any loops, isn't it? In this diagram which I am showing you here, they didn't mention any loops. Okay, they didn't mention any loops. Your wish, any loop direction you can assume. I have assumed both the loops in clockwise direction. You can assume both the loops in anti-clockwise direction. I can draw an arrow mark like this. Okay, this also anti-clockwise. I can mention this as clockwise, this loop as anti-clockwise. I can mention this loop as anti-clockwise, this this as clockwise, and I can mention this as anti-clockwise. Your wish. Loop directions are your wish. Any direction that you want for the loops, you can assume that. Okay, that is in our own hands. Okay, any direction that you want, you can assume. But my advice is, in order to decide what should be the direction of the loops, in order to decide that, you just carefully observe. Here I have mentioned clockwise, isn't it? For both the loops I have mentioned clockwise. You just observe, this is the positive terminal, and I have already told you current always comes out of the positive terminal. So make sure this loop side, this side is closer to this source, isn't it? This side of the loop is closer to this source. Positive is upward, isn't it? So you draw arrow mark upward. So if this is upward, the opposite side will be downward. Similarly, come to this loop. Here there is a source here. If there is no source in this loop, then it doesn't matter. But since there is a source in this loop, you see this is upward, positive is upward, but I have mentioned downward. but actually, so from this source, this is positive terminal, current should flow upward. Okay, current should flow upward, but I have considered downward. Okay, so it is better to follow the direction of the positive terminal. You can assume this also, what I have considered, this loop direction that I have considered is not wrong, but what will happen is, when I determine the currents in this loop, I will get negative currents. Why? Because their actual direction, the assumed direction is opposite to the actual direction of current flow in this circuit. Because of this source, current will flow in anti-clockwise direction, isn't it? If you are listening carefully, you will be able to understand. If the current will flow into this in this loop in anti-clockwise direction because of this source, but I have assumed clockwise. So since I have assumed in the opposite direction to the actual flow of current direction, whatever currents that I am going to determine by solving this circuit, they will be negative. Okay, I will get negative currents. So you can assume any direction that you wish. Okay, it is your wish. Any direction for the loops. You can draw 2 loops, 2 or 3 depending on your circuit. Here I have only 2 individual loops, so I have drawn 2 loops here. So in these 2 loops, I can mention loop currents. I have not mentioned, that is not our subject. We are just discussing what is meant by mesh and loop. You can call it as a mesh or loop. Okay, so any direction you can consider, but better to prefer the direction according to the source in that particular loop. Whatever the source positive terminal direction is there, positive terminal, in whichever side positive terminal is there, from that side you assume the current direction for these loops. That will be easy for you. You will get all positive currents instead of negative currents. Okay, I hope you are able to understand if you are carefully listening to the class. So now let us see what is meant by linear network and non-linear network. So I wanted to compare these two. That's why I have kept both the images in the same slide here. Okay, so linear networks are the networks which consists of elements. This is a network. Okay, it has a source and active element and passive elements. This is a network. This is also a network. It has an active element and some passive elements. So here there is a source here and these are the passive elements. If the elements, passive elements in the given network, passive elements in the given network are resistor, inductor or capacitor, okay, then such networks are known as linear networks. Why? Because the resistance, inductance and capacitance values will always remain constant even though time is changing. Okay, R value, L value, C value, that is resistance, inductance and capacitance will be same. It won't change. Okay, even though time varies or voltage varies, or even if temperature varies, they will remain same. R, L, C values will not change. They obey Ohm's law. I hope you remember Ohm's law. Okay, these elements obey Ohm's law and their values, R, L, C value will remain constant even though voltage is varying, time is varying or temperature is varying. So such networks in which the elements are RLC elements are known as linear networks. And non-linear networks, what will happen is, of course there is a resistor here, but there is an diode here. Okay, there is a resistor, it resembles the linear network, but there is a diode here. So what will happen is, as time changes, temperature changes or voltage changes, the diode value will also change. Okay, so the values in the circuit will change depending on the change in the time, temperature or voltage. So such elements are known as non-linear elements or non-linear networks, and they won't obey Ohm's law. So if diode or transistor is there, they won't obey Ohm's law, but if RLC are there, they will obey Ohm's law. Okay, so let us go to the next, that is lumped network. So lumped network, here again you can see there are RL elements are there. Okay, lumped network are the networks in which if there are passive elements, so there are two passive elements here, one R element and one inductance element, L element. Okay, R and L are the elements here. So these two elements, you can separate them. Okay, you can remove resistance separately, inductance separately, you can separate them. Okay, so physically you can separate them. So if in the given network, okay, in the given network, if the elements are physically separable, then such network is known as a lumped network. Okay. So now let us see next one is distributed network. Okay. So distributed network is the network in which the elements of the network are inseparable. We can't physically separate them. Example for that is transmission line. So we know in our day-to-day life, we all while traveling or when we are outside, we can see the transmission lines. Okay. So transmission line parameters are RLC. Okay. So in these transmission lines, the parameters of this transmission line are RLC, resistance, inductance and capacitance of this transmission line. We cannot separate them. Okay. So these RLC are distributed along the length of the line. Okay, and they are physically inseparable. This is the model of transmission line. You can see RLC here. Okay, sending end voltage, receiving end voltage, source, and this is load. Okay, so the transmission line parameters are RLC. They cannot be physically separable. So such network with whose elements cannot be physically separable, such network is known as distributed network. Okay, so all these things which I have been discussing, they are very, very important. So I hope you are listening carefully. So this is much more important. This is a very basic term which I am going to discuss now, that is short circuit. So you can see a circuit here. There is a voltage source, a resistor, there is another resistor, and you can see a solid line across this resistor R. Okay, across this resistor R, there is a solid line. Okay, so when 2 points of a network are joined directly to each other with a thick metallic conductor, okay, then that is known as short circuit. Okay, short circuit means what? When two terminals of a given network or circuit are connected by a thick wire, metallic wire, that is known as short circuit. So current can easily flow through the short circuit, but voltage will be always zero when any element is short circuited. When two terminals are short circuited, then voltage will be always zero. That you should remember. Voltage will be zero and current will be maximum. Okay. So you can see a resistor here. So from this source, if suppose current of I amperes is flowing, when it comes here, since this is short circuit and since resistor offers, what it offers? Resistor offers resistance. What is resistance? It opposes the flow of current. Since resistance opposes the flow of current, what will happen here? I will take a pointer. So what will happen here? After coming here, flowing like this, from this source, current will flow from here, it will flow like this, it will flow like this, and after coming to this node, this is a node, isn't it? This is at this node, what should happen? Current should divide. Current should divide. So, what is it? I will go to the arrow mark. Yeah. So, see, this current, you know, it is flowing like this. After coming at this junction or node, current should divide. But since it is a solid metal which has been connected here between these two terminals, and since resistance offers opposition to the flow of current, what will happen is current will never divide and whole current I, whatever I is there, you can see here, it is flowing through this solid metallic element, same I current. Instead of dividing here, actually what did I say? At the node current should divide, okay, or add. That's what I said. If there is a junction or node, current should divide or add. But what is happening here? Current is not at all dividing. Why? Because this is opposing the property of resistor is to oppose the flow of current, but it's a solid conductor, solid thick metal. It allows the flow of current, isn't it? Conductor, this is a solid metal, it's a good conductor. Conductor allows the flow of free electrons. So current will prefer to flow through a path in which there is no opposition, instead of flowing through a path in which there is opposition. Okay. Current will always prefer to flow through a path in which there is no opposition to the flow of current, instead of flowing through the path in which there is opposition to the flow of current. So always remember, if there is any short circuit, then current will flow through that short circuit instead of flowing through any other element. So current will not flow through this resistor. You can see IR equal to 0, means current in resistor R is equal to 0. No current is flowing. Okay, no current is flowing through this resistor, even though resistor is there in the circuit, it has been connected in the circuit, but this current is not at all bothering for this resistor. It is because it don't like any opposition, it want to flow freely. Okay, so in whichever paths, it's similar to water flow. So when the water is flowing through a pipe, if there are two openings, in one opening if there is a stone and in another opening there is no stone, okay, two pipes are there. So I can draw a diagram. I don't know whether I have already explained it to you or not. So there is a pipe here. I am dividing this pipe into two parts. Okay, so there is a stone here. Okay, and I will change the color to blue. So here what is happening? Water is flowing. So now when there are two openings, water will try to flow in both the paths. Okay, when there is a stone here, means this is our resistance. This is our resistance, okay, or resistor. So there is a resistor here. So why will the water will try to flow through this? The whole water will try to flow in this path only instead of flowing through this resistor. Okay, so water was there here. If I amount of current, you can always compare water flow with the current flow. So same amount of I current, this will flow in this path instead of flowing in this path. No current will come out of this resistor. So that is known as short circuit. Okay, now let us see what is meant by an open circuit. All of you, I hope you people are noting it down. Note down in your notes. Later I will check. So open circuit. So in open circuit, what happens is, when there is no connection, see, you can see a circuit here. I'm sorry, where is my arrow mark? Yeah, this is my arrow mark. Now you can see a source is there, a resistor is there, and there are two terminals A and B. Okay, so there is no connection between A and B terminals. So when current, there is a source voltage here, a voltage source here. So from here current should start, it will flow, and where will it continue? It must have a return path. Current should always have a return path, remember that. From wherever it starts its journey, it must return back to that terminal. So here, excuse me, so I will take a pointer. So from positive terminal, what is happening? Current started to flow, it has changed its direction. It will flow like this, it should flow like this up to this. After coming to this terminal, where should the current flow? It is open. A and B terminals are open. So it is open. Okay, A and B terminals are open. Where should this current go? So current cannot go anywhere. So no current will flow if terminals are open. So you can see here, I is equal to 0 amperes. Even though source is there, there is a source here, there is a voltage source here, but no current will flow in the circuit if the circuit is open. But voltage will appear across the terminals. Voltage will be there. V is equal to E. Okay, what is V? V is the voltage across A and B terminals. That is equal to source voltage when R is negligible. Small r, R is very, very small. So R is negligible. Of course, no current is flowing means in the R, even though R is there, okay, even though R is there, we won't bother about it because no current flows through it. Property of resistor is to oppose the flow of current. But here what is happening? Current will not flow in the resistor. So even though it is there, it means it is not at all there. Even though resistor is there, we will assume that resistance is not at all there. So what is the voltage across terminal A and B? I will take the cursor. So what is the voltage across A and B? Even though R is there, since no current is flowing, R is negligible, forget about R. So what is the voltage across A and B? This is nothing but source voltage. E is equal to V. So V is the voltage across A and B. Let us assume that V will be equal to the source voltage because resistance is negligible. I hope you have understood what is meant by open circuit. Open circuit means if two terminals are open. Okay, similar to if door is open in our houses, if door is open, okay, so then we can easily move inward and outward from that door, okay, into the room or outside of that room. Similarly, here also A and B terminals are open, okay, so current cannot flow. For the current to flow, there should be a conducting material connecting the terminals. So it is open circuit and this is short circuit. I hope you have understood. Let us get into the actual concept as per the title, that is series circuit. So series circuit. So all these concepts are very, very important. So whatever I have been discussing today are important. So series circuit, there is a resistor here, there is a resistor here, there is a resistor here. R1, R2 and R3. R1, R2 and R3. 3 resistors are there. Note it down in your notes, all of you. As I am explaining, you just note it down. So resistance R1, R2 and R3 are there. So I will take a pointer with the red color. Yeah. So this is the terminal of resistance R1, this is terminal of resistance R1, this is the terminal of, this is one terminal, starting terminal, this is end terminal. Okay. For R2, this is starting terminal, this is end terminal. For R3, this is starting terminal, this is end terminal. So what I am trying to tell is, let us assume I am drawing very neatly. Let us assume this is R1. This is starting terminal, this is end. End of R1 is connected to what? End of R1 is connected to, this is the end of R1, that is connected to R2. The end of R2 is connected to R3. So if elements, if you consider more than one element, if end of one element is connected to starting end of finishing end and starting end. This is the starting end of R1, this is the finishing end of R1. So this is the starting end of R2, this is the finishing end of R2. This is the starting end of R3, this is the finishing end of R3. So if the starting end of one element is connected to the finishing end of another element, or I can say this is R1, this is the finishing end of R1, it is connected to the starting end of R2, then we can say R1, R2 are connected in series. This is the finishing end of R2, this is the starting end of R3. Okay, so R2 and R3 are said to be connected in series. So in general, not to speak technically, if elements are connected end to end, okay, if elements are connected end to end, then they are said to be in series. So R1, I will remove all the ink, erase all ink. So R1, R2, R3, they are connected in series. If they are connected in a straight line, in general, we can say in general language, if they are connected in a straight line, okay, so we can say they are connected in series. But connecting in a straight line is not the exact definition for series connection. Okay, so first the finishing end of one element should be connected to the starting element of the other element. Okay, am I online? So starting end of one element should be connected to the finishing end of another element, and the starting end of R2 should be connected to the finishing end of R3. Okay, so starting of R2 is connected to finishing of R1, starting of R3 is connected to finishing of R2. Now, let us assume the property of resistor is what? It opposes the flow of current. So, there will be some energy wasted across the resistor. So, let us assume there is some voltage drop across R1, V1. V1 is the voltage drop across R1. Voltage drop across R2 is V2. Voltage drop across R3 is V3. Okay, so voltage drop across R1 is V1, voltage drop across R2 is V2, voltage drop across R3 is V3. Now we have connected a voltage source. There is a voltage source. What type of voltage source is it? Can anyone text in the message, in the chat box? What is it? DC voltage source or AC voltage source? Is it DC voltage source or AC? So it is DC voltage source. So this is DC voltage source. So this is a DC voltage source. You can see the positive terminal and negative terminal here. From the positive terminal, current will start and it will flow like this. This is the I. So it will flow like this. It will flow through this resistor. Same current will flow through R2. Same current will flow through R3. Okay. So current value will not change. So you may think that when current flows through R1, some of the energy is wasted in the form of heat. So the current coming out of R1 should be less than I value. So, but we are studying here theoretically, we are not digging into practical case here. We are just considering the ideal case. Okay. So current is not dividing. There is no node here, isn't it? Is there any node to divide the current? There is no node here. Okay. Since there is no node here, current will not divide here. Same current will flow theoretically, not practically. Okay. So practically there should be some energy loss in the resistors. Theoretically we are discussing. We are neglecting the loss here, just simply. Okay. So what is the current in R1? I. Current in R2? I. Current in R3? I. Okay. Same current will flow. So when same current is flowing through same elements which are connected to each other, then they are said to be connected in series. Okay. So I hope you can read here the circuit in which resistors are connected end to end, so that there is only one path for the current to flow is known as a series circuit. Okay. So now according to Ohm's law, what is the voltage across resistance R1? So I will write here itself so that it will be easy for you to understand. I am taking ballpoint pen. So what is the, I am taking red ink. So what is the voltage V1? V1 is equal to current in resistance R1 is I into R1 is the voltage across R1. Similarly V2 is equal to I into R2. What about V3? V3 is equal to where is the pointer? Yeah, I into R3. Okay. So V1 equal to I into R1, V2 equal to I into R2, V3 is equal to I into R3. Okay. How these elements are connected? R1, R2, R3, they are connected in series. When elements are connected in series, what will happen is all the voltage drops will be added up. Okay. All the voltage drops will be added up. So the supply voltage V will be equal to V1 plus V2 plus V3. So what is V equal to? V is equal to V1 plus V2 plus V3. So I will erase all things. Okay, I will go to the another slides. Yeah, you can see here V is equal to what? V1 plus V2 plus V3. So what is V1? I into R1. V2 is I into R2. V3 is I into R3. So you can take I common. If you take I common, R1 plus R2 plus R3 will be, you can put R1 plus R2 plus R3 in a bracket, and you can send I to the other side. So it will become V by I is equal to R1 plus R2 plus R3. Okay. So let us assume V by I is equal to the source resistance or R equivalent, R eq. Okay, R equivalent. Okay, total resistance or R equivalent. So V by I, you just replace it with some notation EQ, R eq. So R eq is equal to what? R1 plus R2 plus R3. Okay. So what is R eq? It is the total resistance. Okay, R eq or RS is the total resistance or equivalent resistance in the given circuit. Okay, Req or Rs is the total resistance, or you can even represent it as RT. You can write it as RT. So RT, or you can write it as RS, or you can write it as REQ. Okay, so when elements are connected in series, you can simply, if you want the total resistance, simply add the resistance values, you will get the equivalent resistance. So you can redraw the circuit. You can replace all the elements with a single resistor. You can replace all the resistors, 3 resistors, instead of drawing 3 resistors. Now you can draw a single resistor whose value is Req or Rs or RT. Simply add R1 plus R2 plus R3, and this is our equivalent circuit. This is known as equivalent circuit. Okay, circuit. I am not writing properly. Okay, this circuit is known as equivalent circuit. Okay, this is known as equivalent circuit. Okay, this is about series. Now let us see the parallel circuit. So you can see here, again I have considered 3 resistors. Again I have considered 3 resistors, R1, R2 and R3, and this end are the front ends of these 3 resistors. This end and this end are the finishing ends of these 2 resistors, these 3 resistors. Okay, these are the finishing ends, these are the starting ends. So all the starting ends are joined together, all the finishing ends are joined together. Okay, all the starting ends are joined together and all the finishing ends are joined together. So, and starting ends are joined together and they are given to the positive terminal of the source, and finishing ends are joined together, they are given to the negative terminal of the source. Okay, they are given to positive terminal on this side, positive terminal on this side, and a negative terminal on this side. Okay, so okay, now from positive terminal of this source, what will happen? Current will start to flow. I current, it has started to flow from positive terminal of this source. Current is flowing like this. It is coming up to this terminal A, where all these front ends, we can say, or starting ends of the resistors are joined at a common point A. And what is happening? Current, when it enters here, Okay. So what is happening? Current is entering here. I current is entering here. I current has entered here. And what is happening to this current? Current is dividing into 3 parts. Okay. Current is dividing into 3 parts. Okay. Current is dividing into what? It has got 3 channels here, similar to water. So in a pipe, water is flowing. Suddenly, in between, what will happen? 3 paths appear in front of the suddenly 3 paths appear. So what will happen to this water? What will happen to this water? Water will flow in this direction, as well as it will flow in this direction, as well as it will flow in this direction. So here current is I is dividing into I1, I2 and I3. Current is dividing into 3 currents, I1 plus I2 plus I3. So what is I is equal to? I is equal to I1 plus I2 plus I3. Okay, I is equal to what? I1 plus I2 plus I3. Current is dividing into 3 parts here. Okay. So the current in resistance, 1 minute, I will take this arrow. So current in this resistance R1 is I1, R2 is I2, R3 is I3. Okay. What about the voltage? What about the voltage? What about the voltage? So across A and B, voltage is constant. Okay, voltage remains constant. So voltage across R3 is V, voltage across R2 is V, voltage across R1 is V. So if you compare it with your RLC, this circuit, in which all the elements were connected in series, so when you compare it with this, here current is same in all the elements. Okay, I current is same flowing in all the elements. Okay, current will be same in series connection, whereas in parallel connection, voltage across each and every element will be same. Okay, in series connection, current is same. In voltage connection, in parallel connection, voltage will be same. So you just mention in the chat box. Okay, you just mention in the chat box in which is constant. In series connection, what is constant? Voltage or current? What is constant in series connection? Voltage or current? In parallel connection, what is constant? Voltage or current? Mention in the chat box. Mention in the chat box. In series connection, voltage is constant or current is constant. In parallel connection, voltage is constant or current is constant. Which is constant? You just mention. I will continue. Okay. Now here, what is the current? I1. So instead of showing you these other slides, I will write here itself so that it will be more easy to understand by looking at this. Now, what about I1 current? What is I1? What is voltage across R1? Voltage across R1 is V. Voltage across R2 is V. See, this is source voltage, that's it. Voltage across R3 is V. So what is I1 value? I is equal to V by R. So I1 is what? I1 is equal to V by R1. Okay, I1 is equal to what? V by R1. Okay. What about I2? What is I2? I2 is equal to V by R2. What about I3? I3 is equal to V by R3. Very simple, very simple. Okay. So if you are carefully listening, you will be able to follow. Okay. If you are following, if you are listening to the class, you will be able to follow. This is very, very important. Okay. Not only see electrical. These are the basics that that every engineer should know. Every engineer should know the basics, whatever may be their branch. Okay, irrespective of whether they are electrical student or not, every engineer should know this. Okay, so simple. So what is the current? I1. I1 is equal to what? V by I equal to V by R. We know the Ohm's law. So I is equal to V by R. So I1 equal to V by R1. Okay, this is it. I2 equal to V by R2. I3 equal to V by R3. So what is I equal to? I is equal to, what did I say? I is equal to what? I1 plus I2 plus I3. Okay. I is equal to what? I1 plus I2 plus I3. So what is I1? V by R1 plus V by R2 plus V by R3. So what is it? V by R1, this is it, V by R1 plus V by R2 plus V by R3. So you can take V common. If you take V common, what will be left over? 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So you send V this side, I by V. V by I is R. Okay. V by I is R. So I by V is R. 1 by R, sorry. V by I is, what is V by I? According to Ohm's law, V by I is equal to R. So what about I by R? I by V. I divided by V means 1 by R. Okay. If V by I is R, okay, if V by I is R, then I by V is 1 by R. So I by V is 1 by R. So you just replace I by V with 1 by R P. Why we are writing P? It's just a notation. You can even write R equivalent, R EQ or P. We are writing P here. Why? Because all the elements are connected in parallel. In the earlier diagram for series connection, all the elements were connected in series. That's why I have written RS. Okay, here I have written RS. Why? Because all the elements were connected in series. Here all the elements are connected in parallel, that's why RP, that's it, nothing else. So you can simply write REQ. Okay, 1 by REQ or 1 by RP is equal to what? 1 by RP is equal to 1 by R1 plus 1 by R2 plus 1 by R3. I hope you people are able to follow if you are listening carefully. Okay, so it's a very important concept. You must know the difference between series and parallel circuits. So I hope you have understood. I am going to the next one, that is series parallel circuits. So in series and series parallel circuits, so it is a combination of series and parallel. Okay, both elements are connected series as well as in parallel. So you can see here, this is R1, R2 and R3. So by looking at the diagram itself, we can say that R2 is parallel to R3. So in order to represent parallel, just draw two lines, two parallel lines that shows that the elements are connected in parallel. If I write R2 double line R3, that means R2 and R3 are connected in parallel. Okay, R2 and R3 are connected in parallel. So now this parallel combination, how they are connected to R1? See, I have already told you, if elements are connected in series, what is constant? Current is constant for series. Current remains constant. Current will be same. Means, if here you can see, here I have mentioned I1. Okay, I1. What is the current in R1? I1 current is flowing. So what should be the current in R2 and R3? R2, here of course by looking at this diagram itself, we can see here current is dividing. So that means, I will erase all the inks. Okay, here you can see current is dividing, I1 is dividing into I2 and I3. So we can see R2 and R3 are connected in parallel. So I2 current flows like this, I3 current flows like this, I3 is flowing like this. Both the currents are adding up. Here both are adding. What is the current coming out of this branch? Whatever current that has entered should come out. What is I1 equal to? I2 plus I3. Here I1 equal to I2 plus I3. Here also I2 plus I3 should be equal to I1. So when you add these two currents, you are getting I1. The current coming out of this whole circuit is I1. Okay, summation of this, okay, currents is I1. What is the current is R1? I1. So R1 is in series with what? R1 is in series with parallel combination of R2 and R3. Okay, it is in series with parallel combination of R2 and R3. Even though R2, R3 are in parallel, when you add the currents of both the elements, the current is same as the current that is flowing in R1. So I can say that these two elements together, they are in series with R1. Of course, it may be a bit complex for you to understand, but you have to understand. You don't have any other option. You just carefully listen and try to understand. What you have to understand is, whatever current that is entering and leaving R1, same current is entering this combination and leaving this combination. So this combination is in series with R1. So you can add R1 value with the equivalent of these two elements. So R2 is parallel to R3. So what is the R equivalent? 1 by Rp is equal to what? 1 by R2 plus 1 by R3. 1 by Rp is equal to 1 by R2 plus 1 by R3. So 1 by Rp is equal to, take the common denominator, what is it? R3 plus R2 divided by what? R2 into R3. So 1 by Rp is equal to what? R3 plus R2 by R2 plus R3 means Rp is equal to what? R2 R3. Just take the reciprocal. I have taken Rp. Rp I have written in the numerator. So this will also interchange. So Rp is equal to R2 R3 plus R2 plus R3. Okay. R2 plus R3. I hope you have understood. See. What is Rp is equal to? Rp is equal to R2 into R3 by R2 plus R3. Okay. Now what is the total resistance? R1 plus Rp. Total resistance is what? R1 plus Rp. Okay. So what is Rp? R2 into R3 by this as I have written here. Rp is R2 into R3 by R2 plus R3. So this is it. Now what is the voltage across the parallel combination? Total voltage equal to, not total voltage, across parallel combination. Voltage across the parallel combination is equal to current I1 entering current into the parallel combination Rp into Rp. Simply it's better to write voltage across the parallel combination. What is the parallel combination here? I will erase all the inks. Okay, what is the parallel combination? This is the parallel combination. So if suppose voltage across this parallel combination is Vp. Vp is the voltage across only this parallel combination. Okay, is equal to what? Current in this parallel combination, total current is I1, entering current I1 into what is the resistance of this parallel combination? Just now we have calculated Rp value. Okay, that's it. So even if you have some confusion, it doesn't matter. All those confusions will be gone while discussing the. You can just write down in the comment box or chat box. I will just reply it to you if you have any confusion. Okay, let us solve some numerical problems and conclude this topic. Few more minutes, I'll conclude. Okay, let us solve some numerical problems. Find the voltage across 3 resistors shown in the figure. So if you are able to solve it, you can solve, and in the chat box you can give me the answer. Okay, you people, you just try to solve it. When you look at the diagram, if you have understood the concept, you can do it very quickly. Okay, what they have asked is, they have asked us to determine the voltage across these 3 resistors shown in the figure. So means I want to determine voltage across R1. So let us assume voltage across R1 is V1. Voltage across R2, let us assume voltage across R2 is V2. Voltage across R3, let us assume voltage across R3 is V3. Sorry. So the total voltage that I have to determine here is V1 plus V2 plus V3, but they didn't ask the total, simply they have asked us to determine voltage across 3 resistors. Okay, they have asked us to determine voltage across 3 resistors. So how these resistors are connected? The end point of R1 is connected to starting point of R2, end point of R2 is connected to starting point of R3. So what is the equivalent resistance or total series resistance? Series resistance RS or RT or R equivalent. What is it? Simply add the resistance values. What is resistance value? 10 ohms, 20 ohms and 30 ohms. I will erase the inks. Okay. The resistance values are 10 plus 20 plus 30. So 10 plus 20 plus 30 you will get 60 ohms. So we have got the R equivalent value, that is 60 ohms. Okay. R equivalent value is 60 ohms. So now I have got the R equivalent value. What about the current in the circuit? I is equal to V by R1 plus R2 plus R3, or I can write V by R equivalent. I can write V by R1 plus R2 plus R3, or I can write V by R equivalent. Just now I have got R equivalent value as 60 ohms. So V is 60, supply voltage is 60. They didn't mention V is equal to 60 volts, simply they have mentioned 60 volts. So supply voltage is 60. So supply voltage is 60, R equivalent is 60, 60 by 60 I have got current is equal to 1 ampere. So current I in the circuit is what? 1 ampere. I hope you people are able to follow. Okay. So current in the circuit, I know the current in the circuit now. What is the voltage across resistor R1? Some VR1. Voltage across resistor, I have written earlier, I wrote V1. So here I have already written VR1. So let us assume V1 or VR1. So voltage across resistor R1 is VR1. What is the current in resistor R1? Current is same, because all the elements are connected in series. Current across R1, R2 and R3 are same. Okay, current across R1, R2, R3 are same. Okay, so current is same. So VR1 is equal to I into R1. So what is I? V by R1 plus R2 plus R3, or you can write V by R equivalent into R1. So V by R equivalent into R1, what is V? 60. R equivalent 60. R1 is 10. So just simplify, you will get 10 volts. Just look at the screen for a second, for a few seconds. If anyone is able to solve, you determine VR2 and VR3 and give me the answer. If you are able to solve VR2 and VR3, you solve it and give me the answer. VR2 and VR3. Okay. Now, so what is VR2? Let us see. VR2 is what? I into R2. So I is what? V by R1 plus R2 plus R3 into R2. So instead of writing R1 plus R2 plus R3, you can write V by R equivalent into R2. So V is 60, R equal to 60, R2 is 20. Just solve it, you will get 20 volts. Similarly, VR3 is I into R3. So I what? V by R1 plus R2 plus R3 into R3. So V is 60, R1 plus R2 plus R3, just solve it, you will get 60, and R3 is 30, just solve it, you will get 30 volts. Okay. So you will get 30 volts, that's it. These are the voltages that they have asked us to determine. Next. So I will conclude this class within 15 minutes. Within 10 to 15 minutes, I think maybe hardly 5, maybe 10 minutes hardly. It will take 10 minutes to conclude this class. So already it's late. So I'll conclude within 10 minutes. So find the next question is find the magnitudes of total current through R1 and R2 if R1 is equal to 10 ohms, R2 equal to 20 ohms, and V equal to 50 volts. Okay. So V is equal to 50 volts. V3 someone have written 40 volts, it is 30 amma, you just see. V by R equivalent is same. 60 by 60 it is 1 into 30. You should get 30 volts, not 40 volts. You just check your calculation. You should get 30 volts. Okay, let's go to the next one. Find the magnitudes of total current through R1 and R2 if R1 is 10 ohms, R2 is 20 ohms, V is 50 volts. Supply voltage is 50 volts. Supply voltage is 50 volts, and R1 is given 10 ohms, R2 is 20 ohms. Okay. So you have to determine what? Find the magnitude of total current, I value, I total. What is I total? What is I total? What is it? Okay. Just a second, system has hanged. Okay.